Hello calculus students and general seekers of truth. Welcome to the lesson on integration of the natural log function and the exponential function. So first, let's kick things off with a little bit of review here. What we have is a function f of x equals the natural log of x. What's the derivative? Well, hopefully you remember that this is 1 over x. And I should say that this only applies when x is greater than 0. So if you recall, the natural log function looks like this, and it has a domain of 0 to infinity exclusive, and the 1 over x function looks like this. And it has a domain of all real numbers except 0. Now when it comes to the natural log function and its derivative, well, the derivative is 1 over x, but we only use the curve on the right here, only the red curve, not this one. That's part of the 1 over x function, but only the positive side is the derivative of the natural log. This will be important a little bit later on. And next we have the exponential function, g of x equals e to the x. What's the derivative? Well, it is itself. It is this beautiful, unique function that is its own derivative. So therefore, the antiderivative of e to the x is itself plus a constant. Okay? In all of our work here, we are going to use c to represent a constant. And the antiderivative of 1 over x, well, this is the natural log of the absolute value of x plus a constant. Now, remember what we set up here, and I just crossed this out? When we take the antiderivative of the function 1 over x, it's the natural log, but the natural log function by itself is insufficient. It only captures the one part of the 1 over x function. In order to have a function that is the antiderivative of the right part and the left part of 1 over x, we need a graph that isn't just defined for the positive values, but also defined for the negative values. So f of x equals the natural log of the absolute value of x looks like this. It's essentially the natural log function, but reflected over the y-axis. Okay? So both of these curves, this one and this one, combine to give us the antiderivative of 1 over x. Now moving on, with these two basic antiderivatives to work with, we can consider some slightly more complicated examples. So here we have a variable in the denominator, and we want to find the antiderivative of this. So this is the natural log of the absolute value of 5x plus 1. However, we must consider the chain rule here, because when we take the derivative of the natural log function, we end up multiplying by 5. And in order to remove or cancel that constant, we multiply by the reciprocal. And of course, we can shift things up and down by a constant value. Same thing here with e to the 8x. Its antiderivative is itself multiplied by the reciprocal of this constant multiple right here, plus the constant. Okay. So hopefully that wasn't too difficult or too tricky for you. The basic idea is just knowing what we know about the derivative of natural log and e to the x, working backwards, and dealing with some constant multiples here for the chain rule. So I will end this video here, and I will start a new one where we deal with yet more complicated examples, and this using integration by substitution.